So the purpose of this video is to review implicit differentiation. And for the first example, I'm going to use the cumbersome notation that we're supposed to be weaning ourselves off of. Okay, but this notation helps you to get conceptual understanding of what happens. Because don't forget that we had a warm-up the day that we started implicit differentiation, and I said, use the chain rule to find this derivative, okay? And you had to drop the power in front, right? Decrease the power by 1. But with chain rule, we always have to find the derivative of the inner function. So what's the derivative of the inner function? F prime of x. Okay, which is why when we know that y is a function of x, right, the derivative of y cubed, right, if I said find dy dx and I gave you y cubed, the derivative of that would be 3y squared y prime. If you want to just memorize, take the derivative like it was in x and then just add a y prime at the end. That's perfectly fine, but the conceptual understanding comes here from the chain rule. So let me start up above, and again, I encourage you to pause the video before I do anything and give this a try. Okay, the first thing that people will often mess up on is where they need to use the product rule. Okay, right in the beginning, I have the product of two functions. So this is my u. This is my v. Okay, so if I come down here, u prime, okay, that's awfully easy. That's just 2x. Okay, now what's v prime? Okay, v prime, just like I did in this example, right? Very similar. Drop the power in front, decrease the power by 1, so that will just become f of x to the first power, times the derivative of the inner, f prime of x. Okay, so we need to use the product rule here. No more product rule, everything else, because these are constants, product rule needs to get used when it's the product of two functions, not when we have constants. Okay, the constant multiple rule says just ignore the constant for a minute, take the derivative of the variable, multiply the constant back in. Okay, so we don't have to worry about any more product rule. Okay, so starting off here, let's see, we would have u prime v, 2x times f of x squared, derivative of the first times the second unchanged, plus the first unchanged times the derivative of the second, which is, gosh, so cumbersome to write all that. I can't wait to just switch over to y and y prime. Okay, but here's the derivative of the second in this f of x notation. Okay, then the rest of this should be pretty easy. What's the derivative of 2x? 2. Right? What's the derivative of 8? 0. Okay, derivative here, no product rule needed. I simply need to take the derivative of f of x and multiply it by the constant that was already there. Okay, so now I'm going to do my cleanup step. Right, so this is to give you conceptual understanding to see that we get that extra y prime from the chain rule. Now when I go to do my cleanup step, everywhere I see an f of x, I get to just put a y. And everywhere that I see an f prime, I get to just put a y prime. Gosh, there's some extra little marks on here. Let me get the eraser out, and that's just a dot from my pencil. There we go. Okay, minus 2 equals 3y prime. Okay, next step is to separate. Often people get to here, they've done a great job so far, they're stuck on what to do. Okay, we separate. We get all the terms without a y prime on one side, all the terms with a y prime on the other. I always aim for wherever I would have the most positive terms. Because it really doesn't matter if we move the y primes to the left or to the right. If you do it differently than me, you will have an equivalent answer, but every single sign on every single term will be different. Okay, but that's an equivalent answer. We talked about that in class, that that's the equivalent of taking the expression and multiplying it by -1/1. Okay, so then factoring out the y prime, that's what allows us to isolate it. Okay, so that's why we need the y primes all on one side so we can factor out. And I'm just going to put a quotation here because this comes down. All right, and then my final answer on this example is 2x squared minus 2 all over 3 minus x squared y equals y prime. Okay, so final answer, right? They're often not pretty, and they often involve both x's and y's, because if I asked you to find the derivative at a point, I'd have to give you both the x and y, because we're not working with functions here. Okay, remember we looked at several graphs of these in class, and you can graph them on Desmos and look at them. They are not functions. All right, so for the next example, I highly encourage you, pause the video, try this one on your own. I'm going to jump straight to just the y prime notation. So if you're back, I want to make the point that this very first expression here, the x times the y, needs product rule. Okay, that is one of the main places students go wrong. Let me switch colors here. So my u is just x. My v is y. Okay, making u prime. What's the derivative of x? It's not 0. Once in a while people try to say that's 0. Derivative of x is 1. Derivative of y is y prime. Okay, so that's the difference. All right, so then I do u prime v, right? So I get y. Oh, my pen is sticking. You can't tell that from home, but all right, there we go. Times uv prime. All right, so this is from the product rule. Then treat the y cubed just like it were an x, right? But because it's a y, we treat it like it's an x, but then we, after taking the derivative, have a y prime at the end. And then the derivative on the right-hand side, nothing special about that. That's just 2x. Okay, so what do we do here? Like I said, lots of people get to this point and then say, now I'm stuck. Okay, so this is where we separate. So I'm going to, and for the sake of writing so much, I'm gonna just go like this, right? I'm gonna kind of save some steps on writing. So this will leave just this expression on the left-hand side. Therefore, on the left-hand side, once that single y is gone, I can factor out the y prime to get x plus 3y squared. And I subtracted y from both sides, so 2x minus y. And then finally, we divide both sides by what was left. And voila, that's an x. Here is our final answer. Okay, so again, thanks for watching.